Okay, we're COMP1050 and it's Animation 2D Tools, Week 7, Part 1. And today's going to be a little bit, we're going to do a couple things differently than other days. We're going to be talking about animation, but we're also going to be stepping it up when it comes to action script and games. After this, of course, is going to be a break. We're going to have a break for about a week for reading week, and then when you guys get back, your project number 1 is due, which is like this top-down adventure game, right? So I've given you a lot of the code already over the last week and maybe the week before for you to build something like that. If you put your mind to it, you can probably put together something that's pretty decent. Now, we're going to expand on some of that, and then when we get back, we'll talk more. I want to try and introduce the Starling framework within a week or two before when we get back. Starling is I think really what we need to do. We need to get to that level of, I would say it's more of an intermediate level programming base than where we're at right now. We're kind of still in the beginner and intermediate phase in terms of ActionScript. Starling requires you to use classes a lot more. Today is going to be the first day we're actually going to use multiple classes for files as opposed to single class. And it's because it's just a pile of programming to look at all at once. If you're looking at a single class and it's 1,000 lines of code, it's a lot of code to look through in one single file, right? So we're going to talk about that a little bit, and we're going to break it up into 5 parts, right? So I'm going to try and stick with each part is like a little video tutorial too, and see if we can get that done today. So the first part is game animation. But this is kind of our lesson objectives for today. We're going to talk about game animation. We're going to do an Airraid kind of game today. We're also going to look at Airraid 2. We're going to kind of update our Airraid. We're going to start with one, and then we're going to move into another one. And then we're going to hit Space Rocks, which is like an asteroids type game, right? So we're going to do all those with ActionScript, and that should bring us up to par with what we did in Intro to Graphics back in the day when we did like our kind of an asteroids program there. Right, so let's take a look at game animation and what we're going to do. So far, we've built games where everything stays kind of in one place. Like the last game we built was this memory game, and you really didn't have any much movement whatsoever, right? So now today we're going to build this Airraid game, which is basically a really simple game where you have an anti-aircraft gun, and you've got these planes flying over, and in the sky, basically, you have this anti-aircraft gun that just basically points straight up, and you fire the anti-aircraft gun, and it fires bullets at your enemy, but only straight up, and there's a limited number of bullets. All right, so if we were going to get a preview of that, let's take a look at Flash. And in your code archive folder, I've got this. It's been broken up. If you look at your code archive as well, there's 5 parts: animation, Airraid, and so on. Let's take a look at the Airraid really quickly. Just preview some of these games. So here's Airraid, the first one, right? We're going to use the same kind of format in the encapsulation we talked about last week, where we kind of encapsulated the game itself within these 3 frames. So the first frame would be your kind of intro screen, a little bit of instructions. And the second frame, it looks blank, but basically what it is it gives you the background. It keeps the score going, and it's kind of hard-coded here. But there's actually the game is actually right in here. It's going to be playing in this particular frame. And then what you have is, on the third frame, you have a kind of a game over frame. So there's like 3 different states, if you will. When we get into Starling, we're going to be talking about a state machine, right? Building a state machine with Starling and talking about different game states. That's different than what we're doing here. This is kind of, again, an intermediary step. More basic, still quite complex, but not as complex as we get into when we get into Starling. So this is the basic setup for the game. And when we run it, right, there's no sound for this game. Just literally, we can move our cannon back and forth, left and right, and we hit the space bar. We have limited number of bullets, shells, if you will, so we can shell the planes as they kind of come by, right? Until we get, well, I guess the maximum points we can get is 20 points, right? because we only have 20 shells. And of course, I've missed like all kinds. And they come from, one time they'll come from the left, the other time they'll come from the right. You can shoot multiple times to try and increase your chances of hitting, but you only have limited ammo. And again, I'm going to, there we go. Bang, bang. And I only have 2 shots left. I'm going to wait. Oh, missed. So I got to go right into the edge here. If I'm waiting for the left side, I give myself more time to hit. Okay, there we go. So I got 11 points, and my game is over. So that's really the game. That's Airraid 1, right? So that's what we're going to talk about right now. Let's take a. But before we get into that, let's talk about animation a little bit more, right? What we do with animation. So in lesson 5, we talked about 2 types of animation, just as a kind of a refresher, right? Last lesson, I talked to you more about the memory game, right? But when we talked about game elements, like the framework for the game itself, we talked about 2 types of animation: frame-based animation and a time-based animation. And today we're going to talk about strictly using a time-based animation for Airraid and for the other games. So how does it work again? Just a review, right? We have a timer, and what we're doing is, instead of how many frames per second, we're going to kind of worry about how many steps per frame. So example, each step would be X number of milliseconds. So example would be, if it was 84 milliseconds, each step, and the second step was 90 milliseconds, then that's the difference between, there's 6 milliseconds between each step, and so on. And there's an example here. If you look at frame 0, the distance is 0, and there's 0 milliseconds. Frame 1, the distance is 127, and it's 317 milliseconds. And then there's a big lag, right? It's a bit of a lag between frame 1 and frame 2, where the distance is only 297, and a lot of time has passed. 740 milliseconds have passed. And then there's a bit. Then it goes to frame 3. So again, time-based animation is really good if our frame rate is kind of depending on the machine, because we want to try and go for is close to 60 frames per second as possible these days with most modern devices. The challenge is that most modern devices, unless you have an accelerated framework like Starling, won't support it. You need something that's GPU accelerated. In order for us to get there, you need to use some kind of advanced framework. But here we're using time-based animation to help us move objects across the screen and to simulate animation without using frames. Or at least not the timeline that we're used to. So how do we code it? Well, we want to keep track of time, right? Like we talked about before. So we have a get timer. We can call the get timer method, which is built into Flash, ActionScript 3. And what we want to do is we want to get the difference between the time when we kind of pull the current time compared to the next time, and so on. And we want to make sure that we do that at the same interval. So it's very similar, but it's not frame-based animation, because frame-based animation will push your machine to go a certain frames per second, whether it can do it or not. So you might have a little bit of lag. That's the problem with that. Okay. So there's a couple movies we're going to look at. One of them is called animationtest.as, because we're going to look at animationtest.fla to understand what we're doing there. So let's take a look at that file. I'm just going to close Airraid down for a second. So that's not what I wanted to do. Let us open up animation test. We're going to go back, and again, in your code archive folder, you're going to have this part 1 animation subfolder, and we want to go to animation test. So here we are in animation test, and if I run it, we've got a bunch of these circles, if you will, and then they disappear. Right, that's really the animation test stuff. I'll do it again one more time so you can see it's different all the time. Every time I do it, it's different. There we go. So a bunch of these, almost looks like a bit of an explosion, right? Actually, if you think about it, it could, if you work it out, you could create these particles, instead of it being, make them as big as they are, you can make it so that these particles, almost like a particle effect, and hand code it. But although I would recommend that you use a framework for that, which is a little bit more efficient. So if you look at the actions on the timeline, there's no action. So again, we're using we're not using our timeline to code. What we're doing is we have in our properties we have a document class called animation test that we're going to look at, and we go to our little pencil tool here, which pulls up, and I'm just going to use Flash Professional again. I won't use Flash Builder because we don't all have it. By the way, I got an email that said, "Hey Tom, what if I want to use Flash Develop or Flash Builder? Can I do that when I'm developing my game?" And the answer is absolutely. You can totally do that. I just need your output. That's as long as I get your output and it's a working game of yours, I can look at your code. We're all good. And if you're using any kind of plugins or a framework or something, then I need to have that too. You need to give me, kind of let me know what it is, so I can, when I'm testing, I can kind of load the same kind of environment that you have. So again, we have this animation test. That's one of the things we have as part of our this thing we're looking at for this part. And what we also have in our code archive is an animation object, animated object, which is another class. We use two classes in this particular case. Right now, they're both using the package. Their package is still the main root for the package. That's what we're going to do there. Right? We haven't really talked about packages too much, but really what packages are is a way of organizing our classes. So when we have a bigger game, and we're going to get to that when we come back from break, how do I organize a bigger game in different folders? Right? Like for example, maybe I want to have my assets in its own package, in its own place, its own folder, right? But right now we're using when we just say package here, it means that we're looking at the same root folder. So both of them are looking at package. So I don't have to import anything from another package. And this is a good example. Here's the Flash package, so that's one root, and then I'm looking at the display subfolder. That's how packages work. So you do the same import. Flash would be the the core library, and then you'd have your subfolder that gives you other classes that you have access to. So you can compartmentalize your code, and that's what we want to do when we build a bigger framework, a bigger game, more complex. Okay, so we got a couple classes we're going to look at here with this one. So what we want to kind of do is put together an animated object. Right? And again, what this does with the animated object is it accepts these parameters. It's the first time we're going to pass parameters into a class. And it accepts a couple of things here, right? So here's my animated object class, and we're going to instantiate an animated object called myAnimatedObject inside my animation test ActionScript file. Okay, and why we're going to do that is because it's almost like we're building a manager, if you will, or an adapter for our animation. And you're going to see that more and more when we start building our more complex games. We compartmentalize or encapsulate some pieces of them and we use a manager to manage certain things. Like for example, when we were doing things with Python, we use groups, sprite groups, to kind of have all the groups almost like grouped together in a sprite. We kind of updated everything in that group. Well, in the same token, we can create a class to do the same thing, and we would just call that a manager of a sort, or an adapter. So again, we're going to take 4 parameters into this animated object function, right? So again, why are we using it, right? Because, and this is when we take a look at what it does, right? Here's our animated object. Well, we're going to it's definitely an extension of movie clip. So movie clip is its base class. So we're going to make a subclass of the movie clip superclass. And we're taking these 4 parameters. Well, the 4 parameters we're taking is x and y, right? So location, right? And then dx and dy. Remember what dx and dy is the change or the difference in x and y, right? That's coming from physics, right? Delta x and delta y, dx and dy is the change in x and y. And we're going to take that information when we have an object. So that's the one thing we're doing. When we create an object off of this animated object class, that's one of the things we also have. We also have a couple of instance variables that we're going to look at, which is speed x and speed y, which is the current speed of the object in pixels per second. Right? So that's another thing that we're looking at. So this could be any animated object. It's not a specific animated object. It's anything. We're creating almost this animated object container, if you will. a container class, right? The other thing we're going to do is remember the last frame's time. So whenever we look at the first frame, you know, when the object starts animating, we keep track of the last time that this thing was updated, okay? And then what we're going to do is, if you notice here, we created this event listener. We add the event listener to this class, and it's an enter frame event. Who remembers what an enter frame event is for you guys here? When we create an enter frame event, we're saying every time a frame ticks by, every time, so frames for this particular movie itself, right? We're listening for every tick, the frame to advance to the next frame. So example, if we're doing it at 12 frames per second, we're listening 12 times per second for the frames to continue to advance. That's how fast we're doing it on a frame-based animation aspect, right? At the same time, we're listening for the difference in time. We're saying the time between frame 1 and frame 2. We're polling the system for system time between ticks. That's what we're going to do. So this is each frame. And each frame, we're going to move our object. So that we're going to call our move object method, or a function, if you will, because they call it functions here in ActionScript. Okay, so that's the first thing. So again, we take these 4 parameters, and our last time variable is initialized with the current value of the get timer, which is basically our current system time, if you will, in milliseconds. That's what it does. Okay. So here's what our move object function does, right? So it's going to move according to my speed. So again, I'm going to get another local variable called time passed, which is our current time minus the poll that we got from last time. So we're saying, how much time has passed, right? How much time has passed? I'm kind of polling the system for that. Well, my last time now is plus equal my time passed. So I'm saying I'm going to add on the extra milliseconds. I'm going to keep adding the milliseconds for how much time has passed. I'm keeping track of how much time has passed every single time. And depending on how much time has passed, so the total milliseconds that have elapsed for game. So let's say, for example, I keep adding up the milliseconds. Well, I'm going to take that and divide it by 1,000. So that's how many seconds have passed, right? And I'm going to multiply my speed by the number of seconds that have passed. So this is where time-based animation is coming in, right? So, and what I'm saying is, my x and y coordinates, I'm going to add my speed to my x and y coordinates. So my x and y coordinates are going to change according to how fast I'm going. Okay, this is all good. So when we build our animated test ActionScript file, right, what I'm actually doing within my animated test AS file is I'm creating a variable. Now, this is bad coding, all right? It's a variable called A, which is of type animated object. So this A, I'm going to take a couple of things in my constructor. I'm looking at x and y coordinates and the delta, the dx and dy values. So here, example will be 5 and -8, right? 5 is the change in speed, right, for my my x coordinate, and this is my change in speed for my y coordinate. That's what this does, right? And then I'm going to add my child to the stage. So using this animated object, right? So I've created a new class, and this is a container class that contains an object that's moving at a certain speed. As we develop it, though, what we want to try and do, here's another, so we've kind of created this animated object, and we've given it hard-coded values. But here's another one. This is kind of what we do here in our circles where they fly apart. We have math.random times 550, right, for the x-coordinate. What is that? It means that it can go from 0 to the size of my stage, the width of my stage. I could have also put in here stage width. That would have been the same, right? So anywhere between 0 and my stage width. And then math.random times 400, which is kind of like saying between 0 and my stage height. So anywhere it's gonna appear anywhere on the screen. And then I'm going to get a random speed, and my random speed is actually another function that we're going to call that it determines my speed from an X and Y perspective. Then I'm going to add that onto the stage. Now let's take a look at what random speed does. So here's get random speed, and I'm declaring this local variable speed, which is a number, so a floating point variable. And now I'm saying, well, it's going to be anywhere between 70 and 100 in terms of speed in pixels, right? 70 and 100 pixels. So minimum of 70, maximum of 100 is what's happening here. And I'm going to say, well, if math.random is greater than 50%, so I'm flipping a coin here. I'm saying if I flip a coin and it's heads, as an example, well then multiply my speed, reduce my speed by, multiply my speed by 0.1. So times equals to 1. I'm actually increasing my speed slightly. It's accelerating it by 0.1, right? Half the time, right? That's what I'm doing here. So again, only half the time. So some particles are going to move faster than others, and it's going to do it in both the X and Y directions. So half the time you might get a particle that moves really, really quickly up and very, very slowly to the right, as an example. Okay. So we have random speed and random directions, and that's where we get that flow. So let's take a look at the whole package and see how it works. So here, let's take a look at the animated animated object. Again, you import your variables, and all we have here is two. We have our constructor, which is right here, which takes the variables x, y, dx, and dy, and then here it actually produces an x and y coordinates based on the speed that we're getting in. So we're getting our delta x and delta y, and we're changing our x and y coordinates according to what we get from the x and y, delta x and delta y that we're receiving in the constructor. In the animation test AS, which is our main movie, think about this as main, and our animated object ActionScript file as a container class. Okay, so here's our main, right? And what I'm doing here is still a movie clip. So one is a movie clip, and the other one's a movie clip. And the animated object container is also a movie clip, right? So it's like a movie clip within a movie clip. That's what I'm doing here, right? Well, first thing I do here is I create this for loop, right? And I don't just create one animated object. I create 50 animated objects. This is right here. So I got a for loop that goes 0 to 50, right? So 50 objects are going to enter the screen at random locations. So here's random x and random y coordinate anywhere on the screen with a random speed between 70 and 100 pixels per frame. It's pretty fast, right? And then it's going to basically determine, when I get my random speed, it could be a positive or a negative direction, right? So I could have a positive direction, which goes down, or a negative direction, which goes up or to the left, right, for my speed. So my speed is totally random. So again, random objects, right? That's all it does. In our library, if I look at our library itself, here's our animated object. Look, it's this circle, right? So we've done a couple things here just so you're not confused, right? The circle with a bit of a border, right, is our animated object. We've actually created a link. So if I go into the circle itself, I right-click, properties, right? And if I actually look at the class definition, so I am linking this external class called animated object, right? This container class for my graphic, right? I'm linking it to my object. Now I don't have to do that, right? Again, I could create all my objects inside ActionScript and not even have a library if I want to. In this particular case, it makes sense that I'm doing that because I've got the circle and I'm giving it an x and y position based on what I'm getting in the constructor for the circle. When I instantiate the object, I'm telling it where to be and what its speed, the change in x and y is going to be, right? And that's why it looks like this. And as if you can tell, they're going to continue to move until they're all gone. It doesn't like respawn or anything like that. Like it doesn't go forever. And I can change that number if I don't like how big they are, as an example, just to do a little bit of a test, right? If I make this 150, So instead of 50, I want to make 150 circles that go on the screen, right? Well, let's try that again. So I didn't save. Whoop. Right now, there's all kinds more, but still they move away forever and ever, right? They don't kind of come back. They don't bounce, right? And there's no wrap. I haven't checked for any kind of border. They just keep going into, off the screen, right? That's one thing. So I can check. I can add more objects this way. That's one thing I could do. And the other thing I haven't done is I haven't actually, when I instantiate the object itself, so if I go back to my object class, so this is my animated object, the circle, right? I can also get some random, I can change my constructor, so not only do I get random x and y coordinates, but maybe what I want is, how about random colors? How about a transparency, a random transparency? I could modify my code so I can get not just a regular, a circle that's just gray, but my circle is tinted. I can add a tint to my circle so that it's red or green, or I can add a filter or something to make it different than what it is, right? Remember, anything that you can do to my circle, my symbol here, which is right here in my library, anything that I can do to my symbol by going to the properties, so if I just double click on this, I'm in symbol editing mode, and I go to properties, anything I can do in here, I can do in ActionScript, pretty much. And again, that would be if I was going to modify this circle, and if I wanted to change the from solid, my border from a solid to a dashed line, I could do that. I could also change my scale, like right now my scale is normal. I could change my horizontal and vertical scale, so I can change that as well. And I could do other things as well. So think about those things when you have an object, and if I want to add opacity, a different kind of opacity or whatever, I can change that very, very simply. Okay. We're not going to explore that, though, because we have a lot to cover. So that's really it for animated object. I wanted to show you that so that you see this is our first piece of animation that we're looking at. Okay.